You are now on mute.
Good morning, all. Welcome to the third day of FDP in FOSS Technologies. Today's session on the topic Assistive Technology is handling by Mr. Akhil SG, the New School, Milano, New York. Now I invite him to start the session.
Hello. Yeah. Good morning, everyone. Uh, my name is Akhil, as you might have just heard. Let me share my screen. Cool. Uh, yeah. So yeah, my name is Akhil. I'm currently doing my graduate studies at the new school in New York. But today the session will be not very engineering. You might not hear a lot of engineering jargons. In my session, it will be kind of like uh, why we engineer in disability or when we are working with person with disabilities and things around it. So I want to keep it like as simple as I can, and like open up focus questions rather than like going around giving up more informations. So yeah. So I'm just going to read a couple of sentences to set like the context for what we are going to like, talk about in this lecture. So uh, yeah, you might have heard it and you might not have heard it. So like the first statement is, no offense, but what's wrong with you? There's no traffic light, so I have to rely on other people to cross the street. If other people are not there, I either cannot cross the street or I take a risk. When you need to speak with a government official, an official in a government building, the receptionist at the front desk often gives you a list of numbers you can call. But if you cannot use the phone, then you cannot talk to anyone. So you have to ask a guard to call for, or and they won't always do it, or just have to go to important places with your own sign language translator. He told me he is taking an extra responsibility by hiring me, and therefore he cannot pay me as much. I quit my college course as my field work assignment was given to us with really short notice, and I had no time to make any arrangements for a note taker. In the end, I couldn't go. So the list goes on and on, and we can also see like I at the end I didn't hear about the meeting. It was on the employee notice board, but placed 1 meter 50 centimeter high and in a very small print. She has been stuck in the third floor of municipal apartment building for 4 months because the building's entryway was accessible only by stairs and the elevator only worked sporadically. So these are some of the statements which are very like real and which we might have encountered or might have heard when we were having like like normal conversation with people. But all these conversations are made by people with like different types of disabilities, uh, and we all are very much aware to what extent the current physical or the digital space is taking care of people with disabilities. But there is something which is kind of common in all these 11 things which is written here, and I would actually love to have a small interaction if like someone around here can unmute themselves and say like what's common in the 11 statements, and from there maybe like we can like slowly go forward, or we could also use the chat. I'll just give a minute for it. Hello. Cool. I think it's still warming up in the morning. It's fine. I just want to confirm, like, Kailas, am I sharing the right screen? Kailash.
Actually, now I can able to see that first slide, able and
But
free.
I'm in the second slide. Oh, okay. But I cannot go to present mode. Okay, fine.
Yeah, it's okay.
Okay. Cool. All these statements were about barriers primarily. Some are institutional, some are physical, some are information, some are communication, some are attitudinal, and some are cultural. Um, and why this is important is kind of like we are trying to understand these barriers, and then our goal is to kind of address these barriers from different perspectives. And technology cannot always address all the barriers which we have mentioned, but we can address the ones which are related to institutional, physical, informational, communicational, and to some extent attitudinal, and that may in turn change the cultural context at large. So this is where assistive technology at large comes in, and if anyone here is interested in assistive technology, a basic Wikipedia could give you like a very like a basic information of what an assistive technology or what AT is. So anything that helps people with disabilities. So why people with disabilities? So before that, like people used to say like specially challenged, abled, differently abled, specially skilled, differently God gifted, and all these things. But the people who are disabled, they choose the word people with disability, people with vision disability, people with mobility disability, and like those kind of things, other than saying they are God gifted or differently abled. So hence the word people with disability. And assistive technology is anything which can support, aid, like help who the people who are experiencing disability in any form. So it could just be like a wheelchair to the talk back feature in Android phone, which we won't always use, or it could also be like an exoskeleton, or like implants in here for hearing, or for cognitive support, and like it could also be like a small game which can help a child learn basic concepts faster. So assistive technology is kind of like a big array of uh, solutions or possibilities which can support people with disability. And yeah, so what what does it have to do with free software or FOSS or IC FOSS, or like why we are here and what's the relation? So some of you might have already guessed by now, like there is this free aspect or cheap aspect of free and open source technology, which makes things like affordable, but there is a larger advantage when it comes to assistive technology and free software. That advantage is customization, because if you know disability, not all disabilities are same. So if you know like somebody with mobility disability, or somebody who cannot access a laptop or mobile, like any of the like mobile phone or like whatever digital devices, different people have different type of disabilities. Some might be able to move their fingers, some might be able to just move one finger, some might be like fully paralyzed under the neck, so they can only use their lips or eyes, voice. Some might not be able to use the voice. So we might be looking at kind of like a like a subset of solutions rather than just one solution in most cases when it comes to assistive technology. So it will be in combinations. You might have like a joystick and a button which can enable somebody to use digital devices. So the reason why I'm stressing the need for people to kind of interact digitally is the physical world has already created a lot of obstacles, and people are not, like, not using it. Especially the one with disability cannot access buildings or, like cafes, libraries, or anything. But when it comes to digital world, there are like possibilities with accessibility research and those kind of things where like we can make it more inclusive by design. And the digital space is an evolving space, so there are like a lot of developing possibilities. So that's why the focus on digital space. So I'm going to share some like different stories of what we have done at IC Force when I was working there a couple of years back, and this might give you uh, like an overview of what is possible. And I will just make it really quick. So the first project which we kind of started with was called like T-Slide Mouse. Uh, and I think it's better to share the video. 1 second, let me.
നേരത്തെ കമഴ്ന്ന് കിടന്നുകൊണ്ടായിരുന്നു ലാപ്ടോപ്പിൽ എന്തെങ്കിലും ചെയ്യുന്നത്. അങ്ങനെ കമഴ്ന്ന് കിടക്കുന്ന ഉടനെ എൻ്റെ തോളിനും കൈകൾക്കൊക്കെ വേദനയുണ്ടാകുമായിരുന്നു. അല്ലെങ്കിൽ കുറേ ദിവസങ്ങളെടുത്തിട്ടേ പിന്നെ അത് മാറുള്ളൂ. കാരണം സ്ക്രീന് എൻ്റെ കണ്ണിനോട് വളരെ അടുത്തായിരുന്നു. അപ്പോൾ എനിക്ക് ഒരു അരമണിക്കൂറാകുമ്പോഴത്തേക്ക് ആകെ കണ്ണിന് ഒരു ബുദ്ധിമുട്ടായിട്ടൊക്കെ വരും. അപ്പോൾ അതോടെ മതിയാക്കും. പിന്നെ കുറച്ച് സമയത്തേക്ക് കണ്ട് ഒട്ടും കാണാത്ത പോലെ ആയിരിക്കും. കാരണം അത് ഒരുപാട് അടുത്താണെന്ന് എനിക്കും അറിയാം. പക്ഷേ കൈ അങ്ങോട്ട്.
So the initial case with Sarasu was like she had 98 or 95 percentage of disability with polio, and she was a writer. She used to write, like staying upside down with her uh, three fingers, which is kind of operation like functional for her. And after that, somebody gifted her with a ThinkPad laptop, and she kind of started using the trackpad button and started writing in laptop. So that's when we kind of met her.
നീട്ടാനുള്ള ബുദ്ധിമുട്ടുകൊണ്ടാണ്. ഈ പുതിയ മൗസ് കിട്ടിയതിന് ശേഷം 1 മണിക്കൂറും 1.5 മണിക്കൂറും ഒക്കെ ആണെങ്കിലും എനിക്ക് വലിയ ബുദ്ധിമുട്ടില്ല. കണ്ണിന് അല്പവും ബുദ്ധിമുട്ട് അനുഭവപ്പെടാറില്ല. മൗസിൽ തന്നെ എൻ്റർ, അങ്ങനെ കുറച്ച് സ്ക്രോൾ ബട്ടൺ ഒക്കെ ആക്കി തരുന്നുണ്ട്. 1.5 മണിക്കൂറെങ്കിലും കുറഞ്ഞത് ആ ഒരു രീതിയിൽ കമ്പ്യൂട്ടറായിട്ട് പ്രവർത്തിക്കാൻ കഴിയുന്നുണ്ട്.
Yeah. So, so one thing like you should understand is kind of like the device which you see here, like the T-slide mouse. It is not like a very complex device. It doesn't have like all those fancy technologies in it. It just has like a two touch operator motor and a joystick, or like a what it's called like a thumb slide mouse. So fundamentally, the external design is kind of tailor made for her hand, and it was done like through 3D printing. And this whole thing was done just by like a team of three. Afsal and Vaishak like work mostly on it, and I was just talking to people about it. So mostly two of them did this. So research project, or like this project per se, was kind of like the human centered attitude which we given to the design process. So uh, like our then research head, like Arun, was pretty straight that like we if we are creating something, we should create something which is useful for at least one person. So we started looking at what is useful for her. And the first phase was basically what we could do, because when we started the second phase, uh, actually she her sickness got a bit bad and she passed away. But she did use our device for a couple of months, and she was happy about it. But the thing is, like the research we did for an individual can be tailored for anybody, because the design is open. The way which we like do 3D printing, and the components and all those coordinate, and everything is open, and everything is free and available in the IC4's GitLab repo. So any student, or like anyone with a slide engineering background could take it up and do this mouse for someone who like they care about. So that part of customization is more important uh, when it comes to disability than like a product which has like a lifetime warranty. So the second main work was called flip mouse. So this thing you see here costs around 1.5 lakhs in the market. But when we researched, like on the components and cost factor, and how we could, make it in an Indian environment, we could drop that 1.5 lakh cost to around under 10,000 rupees. And this was a collaboration which we did with an Austrian university, uh, and they did something which is like and on their like Austrian market, and we try to adapt it to Indian market. So the device is basically SIP mouse. So you will connect it to your like somebody who is having like a mobility disability, who is completely paralyzed under the neck, can use it. He or she will like use lips and a breath to control all the functions in the keyboard. uh, and actually the one we developed was used by a patient in Pallium, India, called Sajidas, and he used the device I think in his last 1 month to convey his last words to his wife. uh, and yeah, and I think I can answer further questions if there is any on the device. So it was not just hardware as open hardwares, like there were also collaborative projects with space in Trivandrum, and those projects were like IEP. IEP is an educational platform for students with disabilities, which is used in schools, and AAC is augmented alternative communication softwares. It's more like an app, which helps kids to like convey their basic things and slowly starts to make sentences and communicate through the app. And later it can be, like we can move the child to like keyboard or like laptop as such. So we cannot like give a laptop to a kid first. So these gamey interfaces kind of helps the kid to interact with their parents or teacher. Sorry. um, then we developed couple of games with Pixie and HYP. The HYP program was in partnership with the Norwegian government, the government of Norway. Yeah, and the other game was kind of like to uh, like give kids like the basic cognitive ability of like recognizing color patterns or recognizing objects and those kind of things. And this game was like identifying a thief, and each level will have like these kind of things, like the thief is wearing a red color, the thief is wearing a yellow color or something like that, and might have like objects around these kind of things. And then the kid will kind of slowly understand uh, using like the color to identify and recognize people, and then do things around it. So basically, yeah, these are all the kind of like a nutshell of what we have been doing, from a range of hardware, software to games to serious stuff to all these kind of things. And if any of like you are interested in kind of exploring what's happening outside right now, there are like a couple of organizations which I know and I can maybe connect. Like Space Out, we have already mentioned, they have done like the IEP, the AACs, and those kind of software interfaces before. So they have like a dedicated work on assistive technology, especially on the software side. Jodurga Maya is a foundation ran by Tiffany Broad, and I they only focus on blind people with vision disabilities. And if like there are projects which are related to this, maybe if you think are useful to them, we can connect. Then Sahridya is our own non-profit. We are doing a social hackathon next month. Starting next month, we are working with Pallium India to develop a solution, which I can share more details with you. And Enable India is based in Bangalore, and they have their own things in Kerala also. Uh, there are other organizations other than this, like niche or like national institutes for disability or state institute for disability, which you can partner based on like projects and other things. And everything which we have done so far is in the assistive tech repo in GitLab of ICFOSS. So before I kind of wind up for Q&A, I would like to share like something which we shouldn't be doing, because this is a space, especially when it comes to engineering final year projects. Most of like even me, we all tend to be very socially active and socially responsible, and we tend to do projects which have some social inclination. But uh, our experience talking to like people from Pallium India or other places who run these disability centers are kind of like, the students will come, they will talk to some patients or employees, and then they will do like a project for on just one time use. And after that, it might not be even useful for the patient, but after that, like they won't be like a promising conclusion or even the beginning. So I would suggest like don't promote gimmicks, uh, because what happens is like these organizations will ultimately lose their trust with college students or anybody who wants to do some real work. And hope is a really dangerous thing, and everyone we meet who have some kind of disability always see like a new person as an opportunity to lift themselves from the current struggles they are having. And technology for us, the consider normal, could be like a very convenient thing which we have and we might use or might not use. But for people who are in disability, it's kind of like their way of life and something which can provide a way of life for them. For example, like if you take the industry of outsourcing and customer services and those kind of things, the text to speech or like voice kind of things actually empowered a lot of people with disability, mobility disability to do work and enable India the training of people who have mobility issues to do this kind of work. Uh, and and the last thing I want to say is kind of like if you are if the FOSS cell which you have is kind of really interested and looking for opportunities to work with people with disabilities, I would say uh, you can like type with organizations or a disability center or like a local organizations and create a relationship in such a way that it's kind of get, you support till the end than just asking some is question surveys and leaving halfway. This is I want to say this because when we were talking to organizations in the beginning, like all of them has expressed concerns of like students coming in and leaving it halfway. So uh, I just want to put it out there. So I can share one more 6-minute video and then maybe I can open for questions. And this is a social experiment kind of thing which the organization I'm part of, Sahardaya, did with the design studio. And I really like the outcome of the whole thing. Let me share the video.
Once upon a time. Yeah, it's a story. Once upon a time on Earth, many mother sapiens, father sapiens, kid sapiens, fellow sapiens walked the whole Earth. They dreamt. And here we made an Earth for walk. We dreamt more. Now we made an Earth for tires. We kept dreaming. Now we are walkers, drivers, flyers. We could be anything we want. Somebody called it evolution. Now look what we have made. We made a world for the dreamers, of the dreamers, by the dreamers. But in this democracy of dreamers, I didn't find everybody. I was searching for some. In the streets, in the market, in the park, everywhere. I kept searching and I failed. Somebody once told me, if you search and fail, be what you search for. So, one peaceful day on earth, we asked some to be what we search for on the roads. And here they are. But the world kept walking. On the walls we made, on the paths we made. We even made the objects walk. But here, world still walking everywhere, climbing, leaping, even over the dead we walk. Now we know where the problem is: the wall, the door, the ramps, the handles, and whatnot. What we built to develop to prosper. Everybody struggled to exist there. But then we heard them say,
എളുപ്പമാണ് ഇവിടെ ഇത്രയേ ഉള്ളൂ. ഒരു കുഴപ്പമില്ല, അത് നമ്മുടെ ബാലൻസാണ്. അത് തേരി കൂടുതലാണ്, ഏറ്റവും കൂടുതലാണ്. അപ്പോൾ ഒരല്പം കൈ ലൂസായി കഴിഞ്ഞാൽ ബാക്കിൽ ഇറങ്ങി വരും.
പേടിച്ച് പോകണം. അപ്പോൾ ഈസി ആയിട്ട് കയറി പോകാൻ എന്തായാലും പറ്റൂല.
Getting into the slope, it was easy to reach to the toilet, and I find it difficult to close the door.
അത് ഭയങ്കര സ്പീഡാണ് കേട്ടാ.
ഇല്ല, പറ്റില്ല, ഇതില്ല, ഇല്ല, നടക്കില്ല. ഇല്ലല്ലോ, ഒരാളുടെ സഹായം കൂടെ ഉണ്ടെങ്കിൽ മാത്രമേ അത് സാധിക്കത്തുള്ളൂ.
അവർക്ക് ഓൾറെഡി ഉള്ള ബുദ്ധിമുട്ട് വെച്ചിട്ട് ഇത് കൂടുതൽ അവർക്ക് എന്തുമാത്രം ബുദ്ധിമുട്ടുണ്ടാവുമെന്ന് മനസ്സിലായി. അതായത് ഓൾറെഡി അവർ ഡിസബിൾഡ് ആണ്, അതിൻ്റെ കൂടെ അവർക്ക് ഇത്രയും ബുദ്ധിമുട്ട് ആക്ച്വലി നമ്മുടെ മിസ്റ്റേക്കാണ് അവരെ അത്രയും ബുദ്ധിമുട്ടിക്കുന്നത്.
I know, my search will never be answered. Even if we answer it with the walls, the doors, the ramps, the handle, I still won't find any walk on the wheels. So the problem is not just what we made. Problem is we think we are the normals. It's high time. Universal be the new normal.
Okay, yeah. Now we have another 20 minutes, and I'm happy to take any questions or give more clarification.
Hello, good morning, sir.
Morning.
Sir, my name is Shaki PS and I'm from Musliar College of Engineering, Shirangi, Trivandrum itself. And I would like to know more about the second product which you showed on your slide.
Okay, one second. Let me share. Okay. So the product here, if you see the nozzle kind of has like 4 sensors around it. So we can kind of move the nozzle with the lips, holding it in our mouth by moving the head, or with like slow movements in the head. And when you sip, you could like perform some function, and when you puff or like when you inhale and exhale in the nozzle, you could like perform different functions. And usually this product is kind of used by people who have like very limited like body movements, like who are like paralyzed. Uh, if somebody has like a spinal injury or those kind of things, like mostly people might not be able to move their legs or fingers or anything. So in those circumstances, we kind of use this device. So the exterior is like laser cut on acrylic kind of thing, and it's pretty. So there is a pressure sensor which kind of looks at how much like you do sip and puff, and based on that you could calibrate different functions around it.
Okay, thank
Did
you, sir.
I answer?
I have seen this type of bed bed usually in hospitals for people who are paralyzed. I have seen in some films, and I know this personally because my father was several years, and unfortunately he passed away 2 years back. Um, he was not that a spine or injury or something, but he had a brain shock. So people who get paralyzed, brain shock like diseases, it won't be easy for them even to control it with their mouth, because they had a stroke and it would affect all the parts of their body, including their breath control, their mouth. They will be having a little difficulty with their tongue. So for them, how can this equipment be corrected or enhanced for those patients also? Because other than their physical disabilities like legs or
Mhm.
hands or even backbone, and they have
Mhm.
difficulty in breathing because this stroke affects their
Yeah,
brain.
understood.
So all the portions of their body that has been controlled by that part of particular brain
Mhm.
will be having difficulties, like their involuntary movements also, like breath
Yeah,
control,
yeah.
their lung movement, diaphragm movement, everything will be
Mhm.
out of control. So how can
Okay,
this
so
be
so
modified?
the patient which we were working with Pallium India, like Sajidas, like he had a nerve deteriorating condition, and it was similar to like the effects of stroke. He could like barely use this device, and after like a week, the condition got really bad, and he couldn't even like move the tongue, as you said. So what we did there was like like pretty non-technology stuff. So if that patient can move their eyes, tracking the eyes might be difficult, but what we could do is like just have like a board, like we could do like basic yes or no based on the person's eye movements. And if the person is learning fast enough, then you could like even put like the whole letters and then spell it out. So after some point, like as you mentioned, like technology won't always be a solution, but there are these things which have been there like forever, which we can like use to basically we when we have these kind of issues, our whole thought should be to like how the person can communicate, or what are the ways the person can communicate. And then like based on that, like if like we should look at like what kind of technology is available, or what kind of like practices out there which we can use.
Okay, thank you. Thank you for the information. And I would like to tell you one more thing. Nowadays, we are
Mhm.
really using the word differently abled or specially abled. I have heard people use differently abled or specially able other than disabled, because disabled, the word itself is a negative word, I think.
So I think the when I started the presentation, I kind of mentioned why I'm using person with disabilities than like differently abled or like any of those fussy words around it. Because when we interact with like people who are actually having disability, when we say like you are god gifted or you are differently challenged, it won't suit well. uh, and like they would rather it's the same with like when we take any community, like if they when we are calling somebody poor, you could rather call that person is living in poverty rather than calling that person poor. So the same thing kind of applies, like rather than like saying the other words to glorify what they are going through, you could just say like person with this kind of disability or that kind of disability. And I'm sorry if I use the word disabled. It might be because like I've been not active in this sector for like last 3 years, so my language might have
Okay, I
changed.
got it. I got it. I will feel like it's a sarcasm.
Yeah.
Actually. Yeah. Okay. Okay. Thank you, sir. Thank you.
Are there any questions? So yeah, if there is no questions, then I will just share the event I was mentioning, and I will wrap up once again.
Yeah, hi, Agil.
Ah,
Hey, how are you doing?
things good, but it's really late. So one second. So like people, if you are in Trivandrum or Kollam or around places, you could actually use this opportunity to engage your students with a challenge. Our organization is building like a designed to lift wheelchairs from a car or like a like a van or anything. And I will ask the organizers to share the details. Cool.
Yeah, like the coordinators, like, do you have any more questions? Radhi sir is typing. Okay. Seems like nobody have any questions. No. So Rajiv sir, can we wrap up?
Hi, good morning, Agil. Sorry,
Hi.
good evening because.
It's almost good morning. It's 1:30 in the morning.
Okay, good. Then how is the things? Then what about your course? Is it research?
I will graduate by December.
Oh, okay, great. Okay. Then Dinesh,
Yeah, sir. You can.
shall I conclude the
Yeah, yeah,
session?
sure.
Yeah,
Sure, sir.
yeah, yeah, yeah. Okay, thank you, Agil, for a wonderful session because you demonstrated what are the things we did here and you explained it very well. I express my sincere gratitude to you on behalf of IC FOSS. You are also now also you are as part of us our community. Then once again, thank you, Agil. Then we will provide a virtual memento to you from the part of the IC4. Then actually, we require your support for our future programs. That means students, upcoming students, also require the support from you peoples. They are not bothered about how the things, how to working the assistive technology kind of area. Then we will conduct the more and more programs in assistive technology, and also the latest one development. I think I don't know whether you know about it. When we visited the blind school and we started to develop some of the component, the like component for the blind students in Kerala.
That's great. I will just drop my email just in case if anybody needs.
Then token of appreciation, we just give a token of appreciation to you, a virtual memento. Thank you. Once again, thank you, Akhil. Bye.
Bye bye.
Thank you, Mr. Agil, for the informative session and for the valuable insights provided. Once again, thank you for your valuable time. Please take up our token of appreciation in the form of a virtual memento for making this program a wonderful success. Thank you, sir.
Okay, so thank you, Agil. Thank you very much. So, dear coordinators, how's the things going? ആക്ച്വലി ഇന്ന് ആൾക്കാർ കുറവാണ്. ഇന്നലെ 60 ലോഗിൻസ് ഉണ്ടായിരുന്നു. അപ്പോൾ ഇന്ന് ആക്ച്വലി 45 ലോഗിൻസേ കാണാനുള്ളൂ. വേറെ എന്തെങ്കിലും തിരക്കിലായിരിക്കാം. ഇറ്റ്സ് ഓക്കെ. സോ നാളെ നമുക്ക് ഫോഴ്സ് എൻ്റർപ്രണർഷിപ്പിൻ്റെ ഒരു സെഷൻ ജയശങ്കർ സാറ് ചെയ്യുന്നുണ്ട്. അത് കഴിഞ്ഞിട്ട് ഒരു പാനൽ ഡിസ്കഷനാണുള്ളത്. അപ്പോൾ പാനൽ ഡിസ്കഷൻ്റെ ഒരു അൾട്ടിമേറ്റ് ഗോൾ എന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ ഇപ്പോൾ നിങ്ങളുടെ ഈ ഫ്രീ ആൻഡ് ഓപ്പൺ സോഴ്സ് സൊല്യൂഷൻസ് പ്രൊപ്പഗേറ്റ് ചെയ്യാൻ നിങ്ങൾ അനുഭവിക്കുന്ന ചലഞ്ചസും കൺസേൺസും എല്ലാം അഡ്രസ്സ് ചെയ്യുക എന്നുള്ളതാണ്. അപ്പം ഞാനിപ്പോൾ നിങ്ങൾക്കൊരു മെയിൽ അയക്കുന്നുണ്ട്. അതായത് നിങ്ങളുടെ കൺസേൺസും നിങ്ങൾ അനുഭവിച്ചിട്ടുള്ള ചലഞ്ചസ് എല്ലാം കളക്ട് ചെയ്യാൻ വേണ്ടിയിട്ട്. സോ അതിനെന്തായാലും റിപ്ലൈ തരണം. ഇന്ന് 5 മണിക്കുള്ളിൽ തന്നെ റിപ്ലൈ ചെയ്യണം. ഓക്കെ. സോ നിങ്ങൾ അഡ്രസ് ചെയ്യുന്ന എല്ലാ ചലഞ്ചസും നാളെ പാനൽ ഡിസ്കഷനിൽ ഡിസ്കസ് ചെയ്യുന്നതാണ്. അപ്പോൾ നാളെ നമുക്ക് പാനൽ മെമ്പേഴ്സായിട്ട് 5 പേരുണ്ട്. അതായത് ഫോഴ്സ് കമ്മ്യൂണിറ്റീസിലും അക്കാഡമിക് കമ്മ്യൂണിറ്റിയിലും ഇൻഡസ്ട്രിയൽ ലെവലിലും പ്രൊഫഷണൽ ആയിട്ടുള്ള ആൾക്കാർ വരുന്നുണ്ട്. അപ്പോൾ നിങ്ങളുടെ എല്ലാ ചലഞ്ചസും കൺസേൺസും അവിടെ സംസാരിക്കും. സോ within the next 5 minutes I will drop you a mail. So expecting your reply before 5 p.m. today. സോ നെക്സ്റ്റ് സെഷൻ ഡ്രോൺ ടെക്നോളജിയിൽ വൈശാഖാനന്ദാണ് സംസാരിക്കുന്നത്. സോ അടുത്ത സെഷൻ വിത്തിൻ നെക്സ്റ്റ് 5 minutes സ്റ്റാർട്ട് ചെയ്യും. എക്സാക്ട്ലി 11 o'clock. താങ്ക് യു.
Our second session on the topic drone technology shall be handled by Mr. Vaishak Anand. He is currently working as Linux Embedded System Engineer at Tata LC. Now I welcome him to the session. Sir, please.
Hi, good morning. Am I audible to everyone?
Yeah, yes, Akhil. No, we can.
Yeah, and is my cam visible? Yes, I guess.
Yeah, yes.
Yeah. So, good morning, everyone. I'm Vaishak. I'm currently working, as I've got an intro, I'm working with Tata Elxsi right now as an Linux Embedded Systems engineer. And before that, I joined Tata Elxsi around 1.5 years back. And before then, I was working with FOSS. And in FOSS, I was actually into the drone labs and assistive technology labs. And for about 2 years, I continued my research with FOSS in both drones and assistive technology. And in FOSS, the main work with drones were actually for GIS-based applications. So I guess we can start. Are we good to go? Or I guess we are good to go. Okay, so let's start with drones. Okay, so the topics that I'll be covering here for drones will be basically what are drones and what type of drones are there in the market that we'll go through, and what are the major drones technologies that is actually fueling this boom of drones and allied technologies. And then I would give us a brief description on what my experience and work with drones are, and what are the documented works that we have done for ICFOSS. And also I'll give a brief overview on how a multi-rotor is designed and what are the components involved. And then we'll go through drone application, And also I have included a small slides on what is the biggest drone community that is available and where does FOSS come into picture when it comes to drones. And we'll end with what is the future of drones in India. So what are drones actually? If you would ask me, a drone is actually an umbrella term. Like it is true, whenever someone says a drone, the first thing that comes to your mind, the mental picture is actually a quadcopter that is flying. But drones are not just quadcopters that fly. Anything can be a drone, something like an aerial vehicle or an ground vehicle or a marine vehicle. Something that is unmanned is usually called a drone. But 90% of us actually has a mental picture that a drone is a flying object that has got 4 rotors. So let's break that stuff first. Drones have got multiple components in it, but theoretically what we are referring to is actually UAV, that is unmanned aerial vehicles. So, and unmanned aerial vehicles is actually a small component of the unmanned aircraft systems actually. So for example, if you are having a drone, for example, I mean throughout the presentation I would be referring to drones as, I mean UAVs as drones through the entire presentation, just to make you feel comfortable here. So in a mission, when you have a drone with you, you have got multiple components actually. One is the UAV, that is a drone itself, and then we have a ground-based control system that will be a joystick controls, as well as a tab or a laptop that could actually give you the live telemetry of what is happening in the drone, what are the statistical data of different components on the drone that is flying up in the air. And then you have a communication system that is established between the control, ground-based control systems as well as a UAV. So UAV is just a component, and the entire ecosystem consists of 3 different parts. Okay, so I mean, I know just to get started, you will be confused with some terms here and there, and I assure you that throughout our my presentation, I should be able to would help you with those doubts with the new terms that you're going to get. So basically, to start with, if you ask me what are the type of UAVs that is present in the market, the most common ones, I would say you have 3 different types, the most common ones. One is a multi-rotor, next is a fixed wing, and the third one is a hybrid, that is VTOL. I'll go ahead and say what is VTOL. These hybrid ones are actually the new age tech that is available in the market. It's been around since, I guess, around 2012, 10. I mean, everyone started to get more interest on VTOL, however. But we have 3 different common types of UAVs in the market. The reason why is these 3 different type of UAVs have got 3 different purposes, and the use cases differ from one to another. Okay, so if you start with multi-rotors, multi-rotor is a UAV design where you have got multiple rotors for implementing, the flight capabilities for the drone. So it can be a duocopter that is having 2 rotors, a tricopter that is having 3 rotors, quadcopter, hexacopter, octacopter. And if you would ask me, why not create a multi-rotor with 16 rotors, I would say yes, you can do that. There is no issue, or there is no restrictions on the number of rotors that you can put. But there are some design components that has to be brought in for the number of rotors that you put into a multi-rotor. And yes, we will be covering those design aspects in our future slides. So usually we use a multi-rotor for a mission that is a short range mission. Let's say if the mission is to cover around 5 to 6 kilometers from the where you are observing, from the point where you're observing. So around a 5 kilometer to 6 kilometer radius, you would obviously use a multi-rotor. And the best flight time that is available in the market is about 45 minutes. And believe me, if you're trying to make a multi-rotor, the best you can go forward will be around 20 to 30 minutes. The reason why we are using multi-rotors most of the time is because it is having a 6 degree of freedom. And for people who are new with degree of freedom, I would say, please wait till the end of the slide so that I can explain what is a degree of freedom when it comes to a multi-rotor. And then we can go to the next type, that is fixed wing. So fixed wings are usually used for long endurance missions. Let's say for example, in Tanzania or South Africa, there are multiple companies or communities actually working for delivery of antivenom and blood for that is a distance of up to 100 kilometers. And that 100 kilometers flight is actually done using fixed wing drones, not using flights, not physical transportation using with cars or ships, or I mean boats. It is currently using fixed wings drones that they are shipping all these blood and antivenom in case of an emergency. Because 100 kilometers travel for a drone, let's say it should cover 100 kilometers in 1.5 or 2 hours. If it is by road, it will take a day. If it is by a boat, it would take more than a day. So currently, this tech is actually used in the remote places of the world, and we are still waiting for that AI or that tech to reach us. And it can be used to cover a large area, and the flight speed when compared to a multi-rotor is too high for a fixed wing. And then we have the best of the two worlds, that is hybrid VTOL. VTOL actually stands for vertical takeoff and landing. So I guess the image that I've given here explains what a VTOL is. Even though the new generation VTOLs doesn't look alike for the image that I've given here just for representation. However, I guess this image should speak what a VTOL is. VTOL is actually a fixed wing that is having the multi-rotor components into it. That is, for example, you are in a cityscape, but you want to travel a 100-kilometer flight. So these multi-rotor components that is inside your fixed wing will help you give a vertical takeoff. Okay, and then in mid-air, you will be shifting to the fixed wing, and the lift is actually created by your wing, and a single rotor will be working towards the entire flight. But for landing, we'll again switch over from the fixed flight to fixed wing to our multi-rotor components, and then use the multi-rotors to gradually decrease our altitude. So VTOL is currently gathering a big traction in the drones ecosystem, and people are more interested in VTOLs right now due to their maneuverability and getting 6 degrees of freedom on areas where you don't have much space to take off or land, and giving long endurance flights. But there are downsides for VTOL also, because the control systems required for VTOL is much more complex when compared to fixed flights or multi-rotors, because the control systems is required. I mean, we need both the control systems on to the same aircraft, and the entire flight controller should take care of both the multi-rotor components as well as the fixed flight components. And also during mid-flight, the drag induced by the multi-rotor components is much more compared to a plain fixed wing. So yes, VTOL has its downsides, and the production cost for a VTOL is much more higher than fixed wing or a multi-rotor, because it has got both the components into the same drone, and yes, the production costs are high, and maintenance is also high when compared to other models. But yes, it has got many upsides. That is the reason why VTOLs are actually taking a big traction at present. However, we'll go ahead and check why this big boom is there in our market for drones at present. So basically, if you look at the market, or like almost all colleges, all students or all startups currently are back of AIs and drones. They would say, I mean, because I've got some teams from some reputed colleges coming to me and asking for support in drone projects. And there are some teams that actually use drone technology for everything. Like I've got a team some from one college asking if we can use a drone for harvesting coconuts. So I would say yes, you can, but that is not the apt tech for doing so. But this drone technology or the interest in drone is actually fueled by many major technologies in the market. The first thing, if you would ask me, I would say is the autonomous flying capabilities. Like even this was the key major technology that we developed in ICFOSS, and that enabled us for doing our projects in ICFOSS. If you ask me what is an autonomous flying capability is, I would say take off from a point A, fly to a particular altitude, fly a particular pattern in the air for this much long time, go to these points, geospatial points, take data from those points, land on a site B. All this thing happens without any human intervention in between. Now, autonomous flying capabilities actually is one of the major building blocks or the components that is actually fueling the drone technology market. Like if you would ask me, for example, for Amazon, they are researching into development for autonomous delivery for their purchased products. That is mainly using autonomous flying capabilities. So there is too much research of the existing technology that is used for autonomous flying. And when it comes to autonomous flying, it is not just outdoors. There are big and huge amount of money and research involved into autonomous flying capabilities that are happening indoors, because autonomous flying that is happening outdoors is actually theoretically easy when compared to flying indoors, because outdoor, yes, you have got multiple obstacles, but if you reach a particular altitude, then you don't have much obstacles there. And the location, the geolocation is actually given by the GPS modules. But when it comes to indoors, it is too hard to get the the location of the drone in respective of the environment, and there are too much obstacles of varying height and width to be handled in an indoor flying environment. However, as I said before, there is too much of money and research involved into autonomous flying capabilities. And the next thing would be surround awareness. If you ask me what a surround awareness would be, I would say like almost everyone uses the drone for the same purpose. Like you are having an area for observing. For example, it was hit by a flood, or you're having an earthquake, or a fire just got out on an area. So you'll be using drones for observing that particular system. And there are multiple technologies that is available in the market right now. Thermal cameras, let's say thermal cameras are available. Many, like for example, let's say thermal cameras, then NOIR cameras that catches data using cameras that are able to capture infrared and different spectrums of visible light. So those type of cameras are actually used for monitoring a large area of agricultural land. Let's say 100 acres of agricultural land, 200 acres of agricultural land. The entire observation for a 200 acre of agricultural land for detecting any diseases in the market can be done using a drone, and it would just take less than 45 minutes for observing an entire 200 acres of land. using an NIR or other spectral cameras. And thermal cameras also used by police here and there for detection in case of an emergency, all this kind of stuff. So yes, there are many companies and many products that help us fetching data from an environment, so that you can have a better understanding of the surrounding that you are in. Also, LiDAR technology is there for mapping the entire ecosystem that you're flying in, so that you can create a 3D map of the entire, let's say, of 100 or 200 acres of land that you're flying. And if you would ask me what is the third most important technology that is fueling the boom, then I would say that it is swarm. I guess you must have seen many videos from Intel or in China. It is almost common nowadays. I mean, some days back I did see a video that in China for some celebrations they actually used a swarm of drones for creating a QR code in midair. So yes, swarm is the future when it comes to robotics nowadays, and swarms in drones have got a very big scope in the entire ecosystem. And yes, there are companies that are using a swarm of drones for analysis and inspection of pipelines, factories, and inspection and observations on critical emergency situations, for example a flood again. Yes, swarm is one of the biggest components. If you ask me, what are the top major technologies that are available in drones? And the fourth major thing is the technological advancements that we have that actually helps us in increasing the modularity and portability of a drone. Like some days back, I guess everyone must have seen it, many WhatsApp forwards and all those kind of stuff. Like, you will be getting drones that you can put it in your pocket and just throw it in the air. It should start by itself and then help you take selfies. Yes, those kind of technologies were not even thinkable like 10 years back. But nowadays, due to new age materials and new age tech, we can create drones that can fly for more than 2 to 3 hours to fit inside your backpack. And the drones that we had at ICFOSS would actually go in your backpack and then can map 200 acres of land in less than 15 minutes. So yes, modularity and portability with the help of new age materials and technology actually scales the drone market in the entire ecosystem. And these are the main four components, if you would ask me, are actually fueling the boom of the drones and the drone market that is available. So before starting my work with drones, is there any questions or any doubts on previous slides for anyone? You can either ask with using a mic, or then you can type it in your chat. Okay, fine. I guess, yeah. Saran has replied. There is no questions. I guess we'll go forward then. Yeah. So yeah, I mean, it is too awkward having a presentation without people in forward and in the front, and I'm not getting any replies. That's why I'm asking you. So I guess we can go forward. Ratish is typing. Okay. Ratish, do you have a question? Okay, fine. So I guess we can move forward. So my work with drones, I started my work with drones when I was in college actually. And my college project was actually a drone that was having a LiDAR unit on top of it that was able to map the environment it was flying on. It was actually a drone that was designed to fly indoors and was having LiDAR on top of it. So that you see this map that was created. This was actually created when the drone was actually flying inside our hall in my college. So the LiDAR actually sends a laser pulse when it hits back, when it hits at a obstacle and then is received back by our LiDAR, the time taken would be actually measured. And that would actually help us plot the outline of that environment that you're flying. And yes, it might seem easy, but there are multiple obstacles. Like as I said before, the drone is actually flying indoors, and you have got no reference to where the actual drone is compared to the entire ecosystem where you're flying. So if this is the room, the drone can be anywhere. So yeah, when using the same LiDAR, you should be able to simultaneously map as well as simultaneously localize where your drone is in comparison to the ecosystem where you're flying. So yeah, this was my drone. I was having a LiDAR here on top, and then 4 rotors. It was a quadcopter, and then I was having a Raspberry Pi on board and was using a multi-V for flight controllers. And the entire flight was having, these are the features of the entire quadcopter that I had. It was able to fly for 8 minutes indoor with a total weight of 2,100 grams. And the total thrust that the rotors was producing was 2,800 grams. And the flight controller that I was having was a multi-V. I mean, all these numbers doesn't make sense for you right now, I know that, but going forward in the slide, I will help you understand what is the thrust to weight ratio, how can a flight time be increased, what is the KV rating for a motor, how can a prop be taken from the market, on what basis can we actually go for the props, all these kind of stuff. Yes, they doesn't make sense for you right now, but going forward with the design, a small overview of the design, you must be able to make out what these values actually mean. Then for this last project, the LiDAR was actually funded by Kerala Startup Mission, and because a LiDAR costs around 50,000 rupees in the market. So this project was actually partially funded by Kerala Startup Mission. And then I had an opportunity to work with 3D photogrammetry using drones with FOSS. So if you would ask me what a 3D photogrammetry is, just as I did for using LiDAR indoors, you are using a laser pulse for actually creating a 2D map or a 3D map of the ecosystem where you're flying. But what if I'm trying to create a map, a 3D map of 200 acres of land, or let's say 1,000 acres of land? It'll take time when you are using LiDAR, and the range of LiDAR actually varies from here and there. So there is a possibility called 3D photogrammetry that we can use. We can do using a single camera. Before going through the slide, let me give a small example on how we are actually mapping the world in 3D using just one camera. So for example, let's say, for example, this is an object I'm having in the ground. And if I take photos from every perspective of this object, okay, and when I cross stitch every photos that I'm taking and then cross plotting values from all these photos of this single object, I should be able to make out a perspective height, width, depth of this object. Am I right or wrong? Because from all these images, I'm actually getting a perspective of the same object. So let's say, even though I won't be able to get the actual width of or the width or height of this object, I should be able to get a perspective height and width and depth of this object in relation with each other using multiple photos. So using the same principle, we started our research in FOSS. We used a drone that had just one camera, but what we did was we just take off in one place and then we fly a crisscross platform. A crisscross pattern in air, okay, and like this, you'll go crisscross, and you'll create a grid in air, and we will be taking photos that is having about 70 5 to 80% overlap between each other. And all these photos are then taken down. Then we will be adding more data into those photos, like in which angle the photo was actually taken, what is the drone's pitch and yaw axis, and what is the camera's roll axis, and we fix the camera to a 10 degree from the nadir, so that doesn't shift, and in what altitude the photo was actually taken, and what is the geospatial, GPS locations of those photos. After putting in all these details into that photo, then we use the tool called Open Drone Maps. It is an actual open source project. It's a huge project when it comes to 3D photogrammetry, and many companies and governments all over the world is actually using the Open Drone Maps. At ICFOSS, we had a close relation with ODM, Open Drone Maps, and we had got teams, Stephen, everyone from Open Drone Maps actually visited Kerala. They were with us for more than 3 to 5 days, help us map many places in Kerala and create a 3D map using ODM, Open Drone Maps. So if you ask me what are the toys that we played with at ICFOSS, I would say we had a hexacopter and we had flying wings. All these drones are actually researched in-house and produced in-house, and everything from nut and balls were actually assembled and made in here in ICFOSS. So the hexacopter that we had a flight time of 18 minutes. Okay, was stable up to 300 meters in altitude, and had a total weight of 2,300 grams and a total thrust of 6,200 grams. And we were able to map around 200 acres of land in less than, let's say, 15 or 12 minutes. We should be able to map around 100 to 200 acres of land at 300 meters altitude. So it depends. Like if you are flying much higher, you'll be able to cover a large area of land. If you are flying closer to the ground, you'll be getting better resolution images, but you'll be covering less area of land. It depends upon what feature that you're trying to capture in the real world. So if you just need to get a terrain, you can fly much more higher. If you need a much more terrain that is having much more resolution, then you can fly at a lower scale. That was the hexacopter that we had, and we had 3 flying wings. Actually, the 3 flying wings, one was that the top one that we were having was our first generation flying wings, and the last one, the red one, was our 3rd generation flying wings. These guys were having a flight times of roughly 35 to 40 minutes, and were able to cover a huge area for mapping. And yes, the total weight was 1,100 grams, and the thrust that was created by the motors was around 1,150 grams. But the rest of the lift was actually created by the wing. So going forward with the design documentation, I guess you will be able to make out what these numbers would actually mean. So this is just a sample of the sample output of what we had from flying. See this map, this we created using our hexa and flying wing at Vagamon. This is 550 acres of land. Okay, there's a small area in Vagamon pyramid. Okay, that we have mapped the terrain here. Like if you would ask me, can't you get the same data from a satellite map? Yes, you can. But if you would ask me what is the best resolution that you get from a satellite map, I would say it is around 50 or 100 meters. But when it comes to a map that is developed using drones, the resolution that you're going to get is around 5 centimeters. Like if, for example, if you are having a scale that is put in ground, and then you could actually measure that. And with this data that I'm having in front of me, you could actually see, okay, for example, it is raining, it is raining in pyramid for about 12 minutes, and you are getting this many centimeters of rain. You could actually use this map to create a water flow path or a simulation on how the water will flow from one place to another, where it will be flooding and where it won't be flooding. Or for example, we also had another requirement from one of our clients, like um, in one place of this mountain, in one side of this mountain, from morning 8 o'clock to evening 6 o'clock, how many hours will I get this much amount of sunlight? We can actually track it using this 3D maps. So, or for example, if you want to remove an entire mountain from this area, you can actually calculate how much land will have to be removed from this area and how many truckloads will be actually required for truckloads will be required for removing the entire land that is being excavated from this particular area. This is a small 3D diagram of the Greenfield Stadium here in Trivandrum. Okay, this drone, I mean, this is the raw output from our open drone maps. Like mostly what companies do is they take the output from their tools and then retouch it, rework it on it using different artists. I mean, artists actually draw on these data to make it much more clear and sharper. But after a research of 1.5 years with IC-FOSS, we were able to make out outputs that were about 60 to 80, I mean not 60, 70 to 80% sharp and clearer comparing to other proprietary outputs that were in the market. And these data doesn't need retouching after processing it in our tools. And also that, I mean, 3D modeling is one of the possible outputs that we have from our drones. We also had see this on towards the left, we were having let's say a drone map that is having a higher resolution aerial overview of a particular area. You could actually zoom in and then see what is actually happening in ground. What is the potholes that is in the road? What is the width of the pothole and what is the depth of that pothole? It is that much. I mean, if you ask, it is having that much of a resolution when comparing to those satellite images that we get. And towards the right, you actually can create a vegetation map of the area of where you're flying. The image that you see in center is actually used using an IR camera, and the data actually cross plots the vegetation in that particular area, and you could actually find out if there is any diseases that is being affected to any plants in that area, because in different spectrums, I mean, if a plant is affected by a particular disease, there will be some changes in the shade of leaves in different spectrums of light. Even though it is not visible with your naked eye, if you are using a no IR camera or different spectral cameras, you should be able to find out if a particular area is affected by a particular disease or not for a particular type of plants. This technology is actually used in agriculture worldwide for tracking huge areas of land, because it is not humanly possible to go ahead and observe 200 or 600 acres of land. It would take much time, and drones are currently used for observing them. And we have, as part of our research, we have also given out documentation on how to go forward and develop technology so that you could actually observe huge areas of land and then understand if the spread of disease or unavailability of water, all this kind of stuff in the land of more than 200 acres. I guess everyone is fine till now. So is there any doubts you have before we enter our multi-rotor design? Or is everyone fine?
Sir,
yeah.
Can we use this drone in certain climatic conditions like heavy rainfall?
If you would ask me, I would say yes, you can, and also yes, you can't. It depends upon the design factors or the design components that you put forward. Um, if it is raining heavily, I wouldn't suggest to go forward with the drone. But yes, if you are designing a fixed wing or a wheel tool that is heavy enough to take on 1 kilometer, 2 kilometer wind, yes, you can go ahead and make a drone. But if you are using a multi-rotor that is only 1200 grams, then yes, you can fly it in the rain, but if it is too windy, you are not going to fly it because it is just 1200 grams and it won't be able to handle itself in a heavy windy day. So if you are designing a drone that is heavy enough and big enough to fly in heavy winds and heavy rains, yes, you can use them. But if you are scaling it to a small project, then you can't. Have I answered your question rightly, or is there anything else?
Yes, sir. Thank you, sir. Thank you.
Yeah, okay. So is there anything else? So I guess everyone else is fine till now. Okay, so I guess we'll go forward with multi-rotor design. What are the components involved? Okay, so initially to start with, in one of my, I guess my first slide, I did mention degree of freedom when it comes to drones. So one more thing, through this presentation, we will be looking forward towards the design aspects, design components involved in the design of a multi-rotor only, not fixed wing or VTOL. Yeah, when it comes to your degree of freedom, you have three axes, X, Y, and Z. Okay. If it is a multi-rotor, you have both translation moments and rotational moments. Translation is going forward in any of the axes. Rotational is when you rotate in a particular axis. So when it comes to a multi-rotor, you actually get 6 degrees of freedom. That is, in all the three axes, that is X, Y, and Z, you'll be having translational moments that you can go forward and backward. You can go in both the directions, okay, and you can climb altitude and reduce altitude. So that means you are having translation moment in all the three axes. And also you can rotate in any of the three axes. You can rotate your drone on your y-axis, you can rotate your drone on your x-axis, and also you can rotate your drone on your z-axis. So that is how you calculate the degree of freedom for your multi-rotor. So usually if it is a multi-rotor, you're going to get a 6 degrees of freedom. Okay. So, and there is also one more misconception between everyone. Like, I've heard people say that when it comes to a multi-rotor, all the blades are actually going in the same direction. No, it is not. It is not. When it comes to a drone, you will be, a multi-rotor, you'll be having, like if you're having 2 blades that is actually rotating clockwise, you would have 2 blades rotating in counterclockwise. Even though all the blades are actually created in such a, manufactured in such a way that it would actually create the upward thrust, but the pitch of the blades are different, so that the counterclockwise blade will create the upward thrust when rotated counterclockwise, and the clockwise blade will create an upward thrust when rotated clockwise. The reason why we are having clockwise and counterclockwise blades is because, for example, if you are having a quadcopter with 4 blades, okay, a quadcopter with 4 blades, and all the blades rotating in the clockwise direction, what would happen? When all the motors start and you create a bit of thrust, the clockwise motors in all the 4 clockwise propellers will induce a clockwise shift to the total drone, and the drone won't be stable. It will start rotating in the clockwise direction because there is a momentum that is created to the opposite side, and it will start rotating. That is the reason why we have both counterclockwise and clockwise blades, so that the clockwise blade would remove the momentum that is created by the anti-clockwise blades that is on the drones. So that is the first thing that you will have to understand. In a multi-rotor, all the blades doesn't turn the same way. There will be equal number of blades that are turning on opposite directions. And so now that we have the degree of freedom and the motor configurations, now we can go forward with the thrust to weight ratio. So if you ask me what is a thrust to weight ratio, I would say, for example, your drone weighs 1000 grams, that is 1 kilogram. And what if the motors on board can only create a thrust of up to 1000 grams? It is not going to go anywhere. So what we have to do is that the weight of the drone should be less than the total thrust that is created by the motors. So if you would ask me what is the that's the minimum, that's the bare minimum configuration that you would need. If you are having a weight of 1000 grams, you should at least need the drone to create 2000 grams of thrust with the full throttle. Okay, that is the bare minimum. But theoretically, for the drones that we had at IC-FOSS, okay, for example, the hexacopter we had at IC-FOSS, the total weight was 2300 grams and the total thrust was 6000 grams. So it is around 2:1 ratio. Like you have 2 times or 3 times, not 2:1, 3:1. So you have almost 3:1 ratio for the thrust to weight ratio for your mapping drones. So theoretically, the mapping drones are around 3:1. Okay, racing drones or aerobic drones are around 5:1 or 6:1. That is 5 times the thrust of the actual weight of the drone. So for example, if it's a 1 kilogram drone, the thrust that is actually created by the motors will be around 5 or 6 kilograms. So the drone will be too fast at maneuvering, but it won't be stable enough when compared to a mapping or cinematography drone, because increasing the weight increases the stability, but increasing the weight reduces our maneuverability. So mapping and cinematic drones are actually 3:1 or 2.5:1 thrust to weight ratio, so that you will get much more stability and the maneuverability is not rapid enough so that the cameras start shaking. So that is a thrust to weight ratio. And if you ask me what is the flight time, that is a major design component for a drone, I would say that this is the formula for calculating the actual flight time. The battery capacity, that is, let's say, the battery capacity for the drones that we were having was around 7000 mAh batteries, LiPo batteries. Okay, so battery capacity would be 7000, and what is battery discharge would be, theoretically, a LiPo battery shouldn't be discharged 20%, less than 20% of the total discharge capability. So let's say, like, you can discharge only up to 80% of the battery, that will be 0.8. And the average current draw, for example, one motor would draw 20 amps when creating a thrust of 200 grams. Okay, so that we can calculate an average current draw for lifting a 1000 gram motor, 1000 gram drone using 4 rotors. So for example, if it is a 1000 gram drone, each rotor should actually create 250 grams of thrust for lifting up. So 250 grams of thrust would translate to, let's say, around 2.3 or 6 amps draw. It depends upon the motor. 6 amps draw, for example, for that particular motor, and into 60 would give you the entire flight time for the drone that you're about to design. And when you are selecting the motors, selecting the propellers, that is where all these numbers actually come into play. Like, for example, if you want to design a mapping drone that is going to be 1200 grams, then you know that if it is 1000 grams, you should be having a total thrust of at least 3000 grams. So 3000 grams of thrust is that you will go ahead and look into the market for the best motor that is available, and then in the motor spec sheet it would say that, okay, a motor can produce this much thrust. For example, a motor can produce 1000 grams of thrust in these many amps. Then from that you will decide how many number of motors are actually needed for that particular multi-rotor that you are going to design, so that the thrust will be equally distributed across all the motors. And also the total amps drawn will be the amps drawn by each motor into the total number of motors that you are having on your multi-rotor, plus the amps drawn by other components in your multi-rotor. So these these formulas will actually help you create the total amps drawn, so that you can decide which battery to go forward, the total number of motors and thrust per motor, so that the total thrust that you are going to create for your multi-rotor in comparison to the weight and equipments that is going to go on board your multi-rotor. So if you're referring to a motor spec sheet, a typical motor spec sheet will be like this. For example, this Emax MT3506 motor that is at a 650 kV rating would actually, like, if it is powered using a 11.1 volt lipo battery, okay, and if it is using an APC 2.3 by 4 propeller, it should be creating 670 grams of thrust at a current draw of 6.8 amps. So these kind of charts are actually given out by the manufacturers, so that you can compare which blade to use, which battery to use, so that you can create this much thrust at this much amps draw. So if you would ask me from where you should actually start designing a drone, I would say start with the things that are required in your drone, then approximate weight, and then go ahead and check the BLDC motors that are available in the market, and then go through their entire spec sheet to make a correlation between the thrust, the propeller to be used, and the amps drawn, so that you can finally decide the battery or the capacity of the battery to be used. Okay. And if you ask me what are the entire components involved in a multi-rotor, I would say that first you have a flight controller that is going to handle the entire logic of the entire flight. The flight controller that we had in IC FOSS was a Pixar Cube that was actually having two flight controllers on board. So that if one flight controller, something happens for one flight controller in the mid-air, it would actually switch over to the other flight controller, and the drone would actually return back having a safe flight. And you'll be having a flight controller. You'll be having ESCs, that is electronic speed controller units. Okay, these ESCs are actually used for controlling the BLDC motors that are on board. Okay, and you'll be having the battery and the GPS units. And if you are having a camera on board, it will be a gimbal camera. We will be also having a gimbal for controlling the camera's X, Y, and Z axis. Okay, and a receiver and a telemetry units for sending and receiving data from the drone to our ground control station units, that is your laptop and your controller units, and as well as a GPS module for if it is an outdoor flight, for getting the GPS points on where you are actually flying. So till here, does anyone have any doubts, so that I can help you create a better overview on how to design a multi-rotor? Are there any doubts here? I guess there are no doubts. I'm very sorry to rush through the entire topic because I've got only 1 hour and the entire drone and its ecosystem is a big topic to cover. So I just wanted to give an overview of everything in the ecosystem so that if someone comes ahead and asks you about drones tomorrow, at least you'll be having an overview on where to start with, how things are working, and to give a better understanding. So yeah, now comes a question: where is FOSS and where are its major? What are the major players in the entire drone community? So, if you ask me, 60 to 70% of the entire drone industry actually runs on open source codes and open source communities that is available, that is present throughout the world. So, like, let's start from the communication perspective. And your ground control laptop or tab is actually using many protocols. And if you take the top two protocol, one is a proprietary protocol that is used by DJI, and the rest, almost all companies use the Mavlink protocol, which is an open source protocol that is available in the community. And this Mavlink is used by almost around 70 to 80% of the drone companies in the entire world. And for tools that are available, or tools or applications that are available in your mobiles or on your laptop, there are multiple tools such as Mission Planner or ground control. All these tools are actually open source. There's a big community for the development of these tools, and underneath it is actually using the Mavlink protocol. And Open Drone Maps, Flown, all these are actually tools that help you for processing and pre-processing data that are actually obtained using your drones. And most of us, almost 70 to 80% of us, actually has an assumption that if you want to create a drone, you should actually create the firmware for the drone to actually fly. No, it is not. Okay. The code or the firmware for the drone to fly is actually given out by multiple communities in the world. And if you ask me what are the top three, I would say that it is Autopilot, Betaflight, and Pixhawk. These communities actually give you firmwares that you can actually burn into your flight controllers, and the drone will actually fly just like that. Yes, there are many tweaking and many balancing and design perspectives that goes into it, but the firmware that they provide will actually reduce 60 to 70% of the burden of creating a drone for yourself. So Autopilot, Betaflight, Pixhawk, they give you complete tutorials on how to create drones. They give you entire documentations on how to tweak with their flight firmwares. And like, if you ask me, there are multiple Indian startup companies that are actually creating drones, and about 60 to 70% of those companies are actually using the firmwares that are provided by Autopilot community. And with the new scenario in India, you're actually required to use NPNT and those kind of tools for flying a drone in India. And Autopilot has got multiple developers and contributors, users from India, that Autopilot actually supports NPNT at present. Yes, it is a vibrant community. I mean, not almost, all the flights that are actually developed in ICFOSS uses the Autopilot firmware stacks. Yes, we have done a rigorous amount of changes in their firmware to tweak with our hexacopters and flying wings, but still, we didn't have to start from scratch. We always had a firmware that was ready to fly, but we had to make tweaks and modifications on those so that it can support this 3D mapping using photogrammetry. So this is a huge community. So if you or your friends or your students, anyone who is interested in drones, please tell them that they don't have to start from scratch. 60 to 70% of the work is actually done, and it is available, and people are using that for producing market ready drones that is available in the commercial market. So if you had asked me, if you want to create a drone for the first time, yes, it is a steep curve. The learning curve is too steep, but if you are ready to invest at least 2 to 3 weeks into it, the fourth week you will be having a drone that is capable of giving out a pretty good flight. I wouldn't say that the best flight, but it would give you a pretty decent performance with the 2 to 3 weeks of time investment. And again, yes, the learning curve is steep. It is steep, but 2 to 3 weeks, that's the best you can do. I mean, that's a minimum that you can do actually for learning and understanding how drones work and how you can actually use the firmwares that are actually provided by the community. And the major drone applications that are currently being used in the commercial ecosystem is actually drones are used for mapping, surveillance, and cinematography, that you all know, and agricultural and infrastructural inspections. Agricultural field inspections are actually used all over North India nowadays, and drones are actually used for spraying fertilizers and stuff. So that is currently happening. And for infrastructural inspections, it is used in the entire world right now for pipeline inspections, factories, and all those critical field inspections that. And the third major application would be payload delivery and emergency response. Emergency response, it is happening as we speak throughout South Africa, Tanzania. Drones are actually delivering medicines, blood, and antivenom through the entire country. I mean, yes, this tech is not available for us. I mean, not present for us here in Kerala, but it is used in the entire world right now. And the technology that we are actually waiting for is currently present in almost all developed poor countries that is actually around us. But the requirement for emergency response or anti-venom, blood delivery, those kind of necessities are not actually present for us here in Kerala or most of our states, but this is a necessity for people here in Tanzania or South Africa, those places, because they have limitation on their road networks and infrastructures. So these technologies are currently being used there for mapping and delivering emergency response components like blood, venom, antivenom, etc. And if you ask me what are the future of drones here in India, the DGCA have actually released new guidelines. Yes, I mean, the first guidelines that they introduced long back 2 years ago, it restricted the development of drones and restricted the hobbyist drone market here in India. But the new DGCA rules and regulations that are coming out actually releases almost all the restrictions that they have put forward. And they have actually categorized drones on based off their weight and not their purpose actually. Nano, micro, I mean, this slide is actually self-explanatory for you. And NPNT devices, it is not yet forced to all the drones. It is like that device would actually restrict you from taking off your drone if you are not having permission from the DGCA. The devices are actually I mean, 1 or 2 devices are actually present in the market, and what actually is required is organizations such as FOSS and other communities should actually invest time and create open source, open hardware designs for NPNT so that other companies and other hobbies can actually use those designs for development for NPNT devices for their particular, personally used drones. And currently, we need pilot license for flying drones. And yes, all the infrastructures are actually up, all the components for getting a pilot license are actually up, but it is not yet enforced. Even though it is enforced, most of the drone pilots are not having pilot license. Yes, nowadays it is hard to test the drones that you make at home, but um, if it is a closed environment and if you are not flying that high, and if you make sure, in IC FOSS we had 25 to 30 page booklet that we create for all the safety regulations that we keep, and we keep a list of checklists that is to be followed before and after every flight. So future of drones in here in India, it is going to be restricted for a little while, but if you have the right set of permissions and if you follow a very rigorous checklist of safety precautions that you have to take while flying a drone, yes, it is a very good technology to invest time, and it is the future, if you ask me. Yes, that is it from my end. If you wish to join our open drone community from IC FOSS, you can scan that QR code there. It is a Telegram group. It is an actually active Telegram group. We have got multiple drone hobbyists and many major key players in our drone market here in that group. It's a Telegram open group. You can join that, and if you want to need any clarifications or doubt or guidings or anything on the drone perspective, you can actually join that group and then put a message there so that someone in the community would actually respond to you. And yeah, that's it. Again, my name is Vaishak Anand, and if you guys need to know any details on my work or on the personal projects that I'm handling, you can visit my GitLab IO page there that is given here. Yes, I guess that is it from my end. I'm already 4 minutes late for ending the session. So now this is the time for Q&A. So if you have got anything more questions or anything on this topic, please go ahead and ask me. I hope I'll be able to, I will pass this slide deck to the administrator. And if anyone of you need the deck that I've presented here for future reference, you can get it from the administrator in the future. Okay. And also I will give the link to my GitLab page here in the chat, and also the Telegram link for connecting to our Telegram group. Yep, that's it from my end. So if you have got any doubts, please ask, or anything related to drone. If that is not for me, I'll be able to answer it for you here.
Hi. Sir, am I audible?
Yeah, Ratish, you broke in between. Now it's audible, I guess. Yeah.
It's like question. Like,
Okay.
what is a research aspect of drone? Because a couple of months back, I've read a IEEE article saying about Internet of Drones. It seems to be very interesting for me. So what I just wanted to know the research aspect, especially in the academic perspective. What are the research side aspect of the drone technology?
Okay. If you would ask me, for example, the final year project that I did in my college. There, the drone was just a medium of delivery. The LiDAR data processing and the 3D modeling of the ecosystem was actually the project. So if you are planning to research in drones, you have got two sites to research for. One thing is for control systems and drone design and development, because almost like the VTOL is actually a new design theory that came into picture like 5 to 6 years back. Before then, everyone was onto fixed wings and multi-rotors, and the multi-rotor design actually came in 10 years behind, 10 or 12 or 15 years before. So you can actually research in two sites. One is the application of drones, like for agriculture or for observation or for inspections or those kind of fields, the application side of development drones. And you can also research onto the control systems, the design, the material used, and yeah, these kind of design components and design aspects for drones. For example, the flight controller that we were using in FOSS, it was actually having two flight control, STM32 processors on board, two IMUs, two pressure sensors, two barometers, everything. So the reason why we used two processors, two barometers, two IMU was that we took data from all these sensors, and then using the redundancy, we were able to cross plot a much more stable IMU and XY axis plots. And the two processors were used so that if one goes down, the other will actually take the drone home. So that is actually a research done into that end. So theoretically, a drone just needs one flight controller, a processor, and one IMU, one GPS unit, one barometer, that's it. But after doing our research, we were able to use multiple sensors, multiple processors, so that you can switch over between each sensors if the calibration failed in midair. So there are unlimited possibilities for research in the drone technology, on the drone design and development aspect. The VTOL that I just showed you was having a fixed wing and 4 motors. Actually, VTOLs doesn't look like that anymore. VTOLs actually are fixed wings that take off vertically like this, and in midair, by shifting their axis, it shifts like this and then it goes. There are VTOL designs that can do numerous things at present. But yes, there is the development or research into those fields are actually lacking at present. So if you can guide people to research on those areas also, it will be great. And application side, yes, people are going behind applications that are currently available, but we need people to research on new applications that are yet to come and are not explored as of now. I hope I answered your question.
Yeah, yes, sir. So more scope is for the hardware side. That's what you said.
No, I wouldn't say. See, if you ask me, if your student is more inclined towards firmware development, let's say reading data or the electronic side of drones, you can ask them into research on that end. Or if, for example, a computer science student wants to develop a tool that will be used for tracking or used for agricultural products, something like that. So they'll be interested more in the application side and not in the design and development of the drone.
Yeah, that's what I asked, because I'm from the IT background, so
okay.
So there is even data analysis too, right? Like
yes.
the data that is
money is actually involved in the data analysis end.
Yes.
Okay. So drone is just a medium of capturing data. That's it.
Okay, so thank you so much, Mr. Vaishak Anand, for the interesting and informative session. I suppose want to acknowledge you for serving as a speaker for this FDP. Sir, please take up our token of appreciation. Thank you, sir.
Thank you.
Okay, so thank you, Vaishak. Thank you very much for a wonderful talk. Actually, Radhakrishnan sir is here, so I think we can start the next session, right? Yeah.
Sure. I'm very sorry for extending the meeting.
Yeah, it's okay.
Okay. Bye.
Okay.
Now I invite Mr. T. Radhakrishnan, currently working as Associate Professor at Indian Institute of Information Technology and Management, Kerala, IITMK, for handling today's last session on the topic GIS. It's my privilege to invite him to start with the session. Sir, please.
Thank you very much. Am I audible?
Yes, sir.
Yes, sir.
A warm good afternoon to all of you. Let me share the screen. At the outset, let me thank the organizers of FOSS for inviting me for this session without losing much time, because I know that this is the last session of the day. So without losing much time, let me go with the presentation. This talk I'm planning to give an overview of since most of the participants are from the computer science and IT background. I'm just trying to focus on some of the data sources and some of the tools which we can use for analytics. 1 hour, as you know, 1 hour is a short time to take an overview, but I promise that this will be exciting for you. So when we talk about geographical information systems, it comes under the broad umbrella of geospatial technology and technology relating to the collection or processing of data that is associated with location. So it is an umbrella technology, and within that, geographical information systems is one subset, and we have remote sensing, or more technically it is called earth observation systems. And the third one is global navigation satellite system, such as GPS, or our own India's IRNSS navigation system. So mainly these three technologies, first level technologies, and then we have the second level technologies that add to this, like image processing and operations research and statistics. All these come under as the second level of this. So putting it all together, even the augmented reality, computer visualization, all this come under the broad umbrella of geospatial technology. And the why we are why geographical information systems is exciting because of the geography part of it, because knowingly or unknowingly the major portion of the data contains this location tag that we will see in the coming slides. Most of our decisions are dependent on the location. So that is why in order to handle and process this geographical information, we use geographical information systems. The rationale is that our planet is becoming more crowded and the demand for diminishing natural resources is growing. That is the essence of it. And the geographical information, which is nothing but information tagged to location, shows us where social, environmental, and economic conditions occur. And reliable and authoritative geographical information provides the framework for measuring, monitoring, achieving the sustainable development goals, improving people's lives, and protecting the planet. So these are some textbook information normally I include in the beginning of my presentations. I just quickly touch upon it. There was an anecdote on happened in 1854. At that time, there was no technology, information technology or satellite technology, GPS, nothing was there. At that time, there was a cholera outbreak in London, and it was spreading out so fast. And at that time, the prevailing notion was that cholera was spreading through air. So the authorities were not taking any measures or interventions to mitigate this, because they just thought that we cannot do anything because this is spreading very fast. At that time, one Dr. Jones Snow was a medical practitioner who had some intuition that is not spreading through air, but he wanted to put some control for the further spread. So what he did, he took a map. At that time, all he had was a print map of the street, London streets. So he started putting dots of the reported cases, and he observed that the first day 1 point, the second day 4 or 5 points, third day 13 or 15 points. So he put a dot on the residence of the patient, and then he saw that it is showing a pattern. So pattern, you all know that it is an arrangement of objects. So the pattern was like it is spreading from a point. There was a what do you call the starting point, and from there it was advancing. It was not advancing in 360 degrees, but it was advancing in certain directions. So he further inspected. He rolled out the map and went to the site, and he identified, he realized that a drinking water pipeline is getting broken, and the domestic sewer from the nearby houses was getting mixed up with the drinking water, and whoever is taking water from that source was getting affected with cholera. So the idea is that he wanted to study the pattern, and from the pattern he was trying to study the process. So in fact, this is what we are doing today also, because we are studying the patterns, and from the patterns we are studying the process. So the patterns are seen as a manifestation of a process. Here the process is controlled by the spatial conditions and spatial characteristics. So this is there's a monument till date about that pump from where people were taking the drinking water. So the definition of geographical information system, textbook definition, is a powerful set of tools for collecting, storing, retrieving at will, transforming and displaying spatial data from the real world. And when it comes to the remote sensing, which is a related technology of GIS, because GIS is an analytical environment, remote sensing is a data inventory technology. Talking about remote sensing, it is a fascinating area where a huge number of satellites orbited by different countries. They collect the information about the Earth constantly on a cyclic basis. So it helps us to monitor the changes in the environment. It is taking these most of the Earth it's not most all the Earth observation satellites are polar orbiting satellites. We have different types of satellites now. Our INSAT is a geostationary satellite. Geostationary means it is the satellite after placed in the orbit, then the satellite moves with the same velocity of the Earth. So it appears to be, for a specific region, it appears to be static. So if the, say for example, our INSAT satellite is placed in a vantage point above the country in Indian continent, and as the Earth moves, the satellite will also move. So that it is 24/7 into 365, it serves the whole country. The purpose is mainly for weather and communication. Whereas Earth observation satellites are different from our weather and communication satellites because it is not geostationary, it is unsynchronous. It orbits the Earth from pole to pole. Always the movement will be from pole to pole. North pole to south pole, then south pole to north pole. So then when it comes from north pole to south pole, it is called descent. From the south pole to north pole, it's called ascent. So it keeps moving, and while it moves, the Earth is rotating so that the next run, it will be covering a new area, adjacent area. That way it covers the entire globe. And each country has got 5 to 10 satellites in the orbit, and some of the satellites, old satellites, are still collecting data. So putting it together, we get a huge volume of the data. It will some statistics show that in a day, one single satellite may collect 1 TB of data. So you can imagine the volume of the data put together. And we know global navigation satellite system. It is a constellation of satellites which give signals with which you will have a receiver in your hand, and the receiver will collect the signals from multiple satellites, and it will resolve its location and time. Now, previously, these type of handheld devices were used for collecting data, and nowadays, we all know that in the mobiles we have very excellent GPS chips integrators which can give fairly accurate data. Now, coming to the characteristics of geographical information system, essentially we will be handling with or dealing with information tagged to location by means of geographic coordinates. And information essentially contain geometry, that means where an object is, attributes, what is an object, its characteristics, and the temporal aspects, like when it was. So where, what, when is the essential components of geographical data. And one more thing is, like, information is systematically managed as layers. Layers means stacks of information with homogeneous geometrical or thematic or logical characteristics. So this is a way, systematic way in which the information is managed. If some of you have already worked with AutoCAD, you know how we handle the layers. The same way we handle the layers in GIS. And it can integrate information from multiple sources and disciplines. Like, you have satellites, then you have drones. The previous speaker gave an excellent account of the drone. So the payloads, that means the camera, whether it is an RGB camera or multispectral sensors or LIDAR sensors or hyperspectral sensors, when these sensors are fitted into the drone as a payload, it can collect excellent information about our environment, and it can be used as for analytics to whether it is for spatial prediction or temporal prediction, or in a combination of spatial and temporal predictions in specific domains such as agriculture, forestry, flood, then disasters, then traffic planning, then urban planning. We all know that almost smart city project is a major technology driver for smart cities, GIS and drone based data collections. And IoT devices which are fixed at specific locations can also contribute to the GIS for analytics. So the information come from multiple sources depending on the type of the discipline in which you are working. If you are working on agriculture, then you need to know the crop calendar, you need to know the soil nutrients, you need to know the soil moisture conditions. Various types of information can be gathered from multiple sources and analyzed, and even you can come out with excellent yield predictions or nutrient deficiency predictions. All these things is possible, and it helps translate and apply scientific principles, facilitate analytics and modeling. It has a powerful visualization, real world visualization, that helps us to, as we all know that a picture worth 1,000 words. These visualizations will very easily and efficiently communicate the complexity of the data. I'll show some visual slides in the coming slides. And it's constantly evolving with scientific and technological advancements, and it simplifies the complexity of the real world processes. So this is just to show you the range of applications we approach with the help of GIS. On one side, we have very complex climate change and climate modeling, and on the other side, we have very simple user-friendly applications such as navigation. Now I'll skip these slides. I'll share this PPT with you because I just want to focus on the visual side of it. Now, this is how we tag information. When we say location tagging, we use, or whatever we have learned in the old geography classes about the latitude and longitudes. These are spherical coordinates. Because the Earth is a spherical object, we have to use spherical coordinates. So this is the way we record location. So when I say location tagged information, or information is tagged to location, this is the base, or this is the coordinate framework we use to collect the information. Now you can think that whatever data you are dealing with, it can be attached with this location coordinate. Say for example, we are studying water contamination, drinking water contamination in a panchayat. We are collecting water samples from say 2,000 wells in a panchayat. Along with the data collection, sample collection, you can also collect the GPS coordinate of the well, so that in a spreadsheet it becomes data, rows and columns of data. 2 extra columns will be there. That will be latitude and longitude. This is all we need to start with. Now you can call this as a spatial data. You can easily plot this data onto a GIS framework with the help of these coordinates, and it will give a location, geographical location with points representing these wells, and each point will have a location, and when you click on the location, you will get its attributes. What is the pH of it, what is the biological oxygen demand, or what is the total suspended materials. So these characteristics will go as a supportive attribute information for the locations. So that is how you build information from the data collection. Now we will I'll give some overview about the data which is available in the public domain, which will help us to do some excellent analysis, and it will also explain the spatio-temporal characteristics of the data. Now you can see that this is a precipitation data. That means the rainfall. We call it precipitation because it's a general word. All the hailstones, everything is come under the precipitation. But as far as our country is concerned, especially Kerala is concerned, the precipitation will be essentially the rainfall. Now you see that the data is into pixels. So this is a model actually. This is a spatial model of precipitation. And how they generate this data? This is available in the public domain, and the organization which shares this data collects data from multiple sources and makes into a fairly accurate model. Now, as to speak about the data, it gives average hourly rainfall for January 2009. So for a specific purpose, what I did, I collected the daily data of January and I averaged it. So the unit is millimeter per hour. So average rainfall. So wherever you see the blue pixels, there the average annual rainfall, average hourly rainfall is high. And wherever you see the red, the rainfall is low, extremely low, or zero. Now, I just when I'm going to click on the screen, now the next data will load. Now this is for April. Now you can see the difference. April, we have rainfall in all these areas. So what does that indicate? That indicates that during 2009 April we had good summer rains. And if you look at the Tamil Nadu side, it is dry, almost dry. And as you go towards east, you can see that this intensity is getting decreased. The rainfall is getting decreased because of the Western Ghat effect of Western Ghats. A Western Ghat will block the rain-bearing clouds to move further into the east. Now we will see another season, June. So in June we have excellent rainfall almost for the whole Kerala. And if you see the scale, it is also increased. The scale is also increased. Now in September we have even more rainfall for the 2009. So now you can imagine I have averaged it. If I had not averaged it, then we can get the daily rainfall data for a year, and the data is available from 2000 onwards. So you can imagine the huge analytical capabilities. Now what I did, I just collected the 2018-16 August when we had the flood. Now if you look at here, it is the highest rainfall is 1 millimeter per hour. I forgot to tell you the units. This is in millimeter per hour, and here it is 55 millimeter per hour. That means 5 centimeter rain, 5 centimeters per hour. So that was the huge. This is this daily data, and this is the monthly average data. So this I did not average it. I just wanted to show you the fairly accurate nature of the data. Now coming to another theme. This is called NDVI, Normalized Difference Vegetation Index. I'll show you how to make NDVI. You can do this. I have towards the end of this presentation, I have included a small tutorial following which you can do this exercise. I'll speak about what the NDVI. NDVI stands for Normalized Difference Vegetation Index. Now, when a satellite is taking an image of the Earth, it takes as tiles. I will show with the help of a software. Now, this software is called Quantum GIS. This is an open source GIS software which is freely available, and it's a open source software. Now, this is a base map. Now, this is the base map. Now, this is what layers are. This is what layers. I have now one layer, the second layer, third layer, and fourth layer. Now, interestingly, the fourth layer is a web map service. That means it is coming from the internet. It's not coming from my machine. It is coming from the internet. Now, we have a plugin here called Quick Map Services, in which you can add any base map. You can add Google Map if you want. You just click add, then you will get the Google Map loaded onto your machine. Now you can see the Google Map. So it is fetching from their server. Now what I have done, I have I have this district layer. Now, there are two types of layers, there are two types of data in GIS. One is vector data and the other one is raster data. I mean, now all these things are included in the school geography textbooks. Now, what is a vector data? Basically, when you represent a data with the help of a point, line, or polygon, then that type of data model is called vector data. Now I will show you the characteristics of the vector data. Now see this, when I click this, see, so I'm clicking here, it is identifying as so this is a polygon actually. This is a polygon, and if you want to shade it, I can use a shade. Yeah, I'm putting a simple fill, so you can see that it is getting filled. Now this this is a polygon data, and each polygon represents a district. So there will be 14 objects in this layer. Each object will have its own associated attribute table. So you can see the attribute table here. Now there will be 14 attribute table. You can select the object from here. Alternatively, you can select from here. There will be an internal binding. So this is a vector format, and I go back and put it on the holo so that I'll get the transparency. Now we have another type of data model called raster. Raster data is, it will be like this, and this is the raw image, and if you want to give a false color, it's pseudo color, it will appear like this. Okay, some stretching is required. So it will appear like this. Now, if you zoom it, it will break up into pixels. So these are the basic two types of data models in GIS. One is the vector, and the third one is the raster. This is called raster model. And if you ask me, why do we have two data models? Because whenever you want to represent a discrete object on the Earth's surface, you will use vector model. And when there is some data which is continuous, it is not discrete, it is continuous, you will use the raster data model. Example of discrete model are, say for example, a district boundary. It has a defined boundary. Then the locations of electric posts, location of houses, location of pipelines. So all these will have a discrete identity in the real world. So you will use vector data. Whereas if you want to study how the temperature is varying, if you take Trivandrum district, the temperature at the far west, and if you take the far east, in the far west we have the coastal line, and on the eastern side we have all these Ponmudi and Agasthyamala, all those things. The temperature will not be uniform. There will be a gradual change. So this gradual change, we cannot represent it with the discrete object. You can't say that there is a line going like this, and this side of the line the temperature is average temperature is 28 degree, and the other side the temperature is 29 degrees. So because the change will be very gradual. So in such cases, whenever you want to represent a parameter or a feature which is gentle, which has a continuous variation, then you will use a raster data model. So now see this zip file. This is a zip file which I have downloaded from a site called Copernicus. Skyhub Copernicus EU. This is a European Space Agency's portal, from where you can click the Open Hub, and from the Open Hub there is a login. You have to register, and once you register, you can search their repository. It is a global coverage, and they have the data from 2015 onwards, and there are different types of satellites, nearly 4 or 5 different types of satellites, and the data is available in every 5 days or 10 days, depending on the type of the satellite. That means from 2015 onwards, every 5th day or 10th day, you can get the data. Another important thing, the data is archived. That means you can take the historical archived data and build models and do spatial or temporal predictions. So this is just one site where you can download the satellite data, and we have similar to this. We have NASA satellite is there, Japanese satellite portals are there, from where you can download the data. I'm giving all the links from where you can download the data at the end of my presentation. Now coming back here now, so yeah, this is where the data, I've loaded the data. So when using this satellite, using this portal, I have to select an area for which I need the data, and then I have to search the details, and then I'll get a zip file and I'll download it. When you open the zip file, you can see that it has got different bands. This is one of the principles of remote sensing. This, you look at here, this is AOT, B02, B03, B03, B04. Each one is a band actually. And I have just downloaded band 2. Likewise, I can load the band 3 image. Now this is the band 3 image. This is the band 2 image. Now this is the principle of remote sensing, that in the satellite, the payload means the data collecting device will have different sensors. It's not one single sensor. It will have different sensors, and each sensor will capture data pertaining to a specific electromagnetic band, and that details I'll give you. Each satellite will give yeah, this is the band. So for example, band 1 collects data in the wavelength of 443 nanometer, band blue 490 nanometer. That means it will capture only that energy. So basically the source of energy is sun, and from the energy from the sun is falling on the surface. Depending on the physical and chemical characteristics of the surface, some energy is absorbed, some energy is scattered, some energy is reflected, and the reflected energy is sensed by the satellites. So when we say one exposure, when one exposure is made, it is actually collecting 12 images. That is precisely what we see here. All these are, it belongs to one exposure that comes as a zip file. Within that zip file, we have individual bands. And depending on the wavelength, it will have specific characteristics. The data will have specific characteristics. These bands, that means an expert who is working with, say, for example, agriculture. Another expert is working with, urban studies. Yet another expert is working on soil. Another expert is working on coastal erosion. Depending on the expertise, he has to choose the right combination of the bands and proceed to the analytics. So that is about the bands in the satellite data. And remember, the beauty is that, or the exciting fact is that, this is just one tile. So if you want to cover the whole state, you have to download the tiles of surrounding areas. And again, the another exciting fact is this is for a specific date. You can see the date here. This will contain 2019-04-04. That means 4th month, 4th date. Now, if you look at the next pass of the satellite, you may get the next satellite on after 5 days from here. If it is January, February, March, April 4, then you may get, say, April 9th or next data. Then that can also be tiled on top of it. So while this gives the spatial variation, if you put the stack of temporal data, you can also study how the data is varying temporally. So spatio-temporal analysis can be studied with the help of the satellite data. Now coming back to this slide, yeah. So look at this. Now what we do for NDVA, there is a band combination. This is actually it is a processed image. I am taking the red band and NIR band. We have different bands. We have seen different bands, out of which I am taking the red band and the infrared band, and I am applying a formula: red plus infrared divided by red minus infrared. That will give the result like this. And what is the advantage? The data normally ranges from -1 to +1. After you apply this ratioing, the whole pixel will be converted into this index value, which will range from -1 to +1. And 0 will indicate water, and any value below 0 will indicate extremely dry and sparse areas, and values above 0 will indicate the vegetation. If the value is very close to 1, that will be totally healthy vegetation. So now you can see I have this for January, and see this is for April. Now see the difference. It speaks a lot of story. Now if you look at the Tamil Nadu, the entire area is dry except for some, this is the Tamraparni river in Tirunelveli. So on the both side of the river, you have the floodplains where the paddy is cultivated. So except that, and here we have the Kambam Theni, Kumali Kambam Theni, that area. There are also some cultivation, but the situation is much good in January. The pre-summer condition, and especially if you look at the Tamil Nadu side, Tamil Nadu gets ample rainfall during the northeast monsoon. That is October-November season. That is why you have this much green in January. But by the time it reaches April, most of the areas is extremely dry. And this is for the entire South India, and the same payload, the sensor data which I was speaking some time back, the same payload can be fitted with drone, and the drone can be used for collecting NDVA for a small area. The advantage is that here the pixel is 10 meter, the pixel size is 10 meter, and if you are using a drone, the pixel size would be 10 centimeter. This is the plus side. The flip side is that, this is the advantage. The flip side is that since it is it gives extremely high resolution data, it is also flown at extremely low altitude when compared to satellite, because satellite, these type of earth observation satellites are launched at 900 kilometers. when it comes to drone survey, we keep the height as 100 meters, 100 to 120 meters. So the advantage is that the aerial coverage will be extremely small for the drone. So if it is for a focused study, so for a experimental study, or for a small plot or something, the drone is extremely good. It will pick up the band-wise variations in a extremely micro level, so that the minute variations in the vegetation health of the vegetation can be picked up by the NDVA. As part of a visit, we had an opportunity to visit Kerala Livestock Development Board. Previously it was called Indo-Swiss project in Munnar, Matupatti. There they have 500 hectares of land, and almost 70 to 80% of the land is cultivated with fodder to be fed to the cows, the cattle. Now we did a drone survey there, and we did this NDVA. We could see that even if it looks as lush green with your naked eye, the NDVA revealed that there is a health of vegetation is very, in some of the patches the health is not so good. But if you look at the naked eye, you won't be able to perceive this. This is because there the nutrient is not properly applied. So even if you are applying the nutrient, there will be some gaps. So these gaps can be extremely picked up, because we could understand from the experts from Livestock Development Board is that the nutrient content of the fodder determines the milk production. That has a strong correlation with the milk production. So they wanted to maintain the health of the fodder to have a satisfactory yield of the milk. Now this is another thematic. So this is all from satellite data. Now you can see that this is land surface temperature of the top layer of the land. It's not atmospheric temperature, it's the land surface temperature. So this gives a pretty good information on bearing on agriculture, as well as there are various other studies like how the water table level, and other drought situations. This gives an excellent idea. Now this is for January, and here the temperature in degrees Celsius. This is 39 degrees, and this is 18.53. Is you can see that in the Western Ghats region, a high altitude region, you have low temperature, and in the interior Tamil Nadu you have very good temperature, and you can see how it is varying with the season. Now what it can offer actually. Now assume that I have all these information and I am stacking with the help of a software like this. In the software I am just stacking it. Stacking means loading the data one over the other, and then there are two approaches. One, I can use the raster data as such, or if I want to reduce the complexity of the computing, I can convert that into vector, because vector data is extremely low in size. So suppose I make equally spaced grid of points on top of this stack, and then for each point I extract the data from the thematic layers. I'm extracting it and saving it as an attribute here. Now you can see that for a selected point, I have extracted land surface temperature for January 28, April 32, June 27, September 26, and NTVA, the precipitation. Now I will get a huge matrix. So like I can create a matrix like this. Now, so these are individual raster thematic layers collected from satellite data, and I am extracting the points and getting a matrix. Alternatively, I go to the field and then I'll have a training data. I collect from the point, I collect from the field, and I have a set of training data. So now you'll realize the power of it. With this training data, you can build a model, and then you can apply it in the test data or full data. You will get excellent, predictions of whatever your study is. Like I can give an example, like agricultural yield or soil nutrient availability or the disaster proneness. What are the, so you have, this is just nothing but regression and machine learning approach. With the machine learning approach, you can come out with fairly accurate predictions. So here there are two points. One is remote sensing, earth observation remote sensing provides an excellent source of information to be used in analysis as predictor variables. And the GIS techniques would provide, GIS techniques combined with machine learning or AI would provide excellent opportunities for fairly accurate predictions of earth and environmental systems that can be used for our decision support. And another beautiful byproduct is that when you make a prediction, you are not just getting concluded with the accuracy of the prediction or the predicted result or residuals. Those things are already there, but you will get an excellent visual output, which you can use the GIS to inspect spatially. You can relate. You can specifically tell that for this particular village or this particular property or farm, this is the condition. So that much accurately you can use this information further for decision making. Now, I'll quickly show some of the other data. Now, this is the data for 2018, 27th, August 27th, when we had the flood, the major flood. So the optical remote sensing data, we have different types of sensors. So this is the optical sensor. Optical sensor is nothing but the normal camera, RGB camera. Normal camera, we use in mobile or the DSLR. The thing is that during the flood, you will have widespread overcast of clouds. It will be completely covered with cloud. You can't see what is on the ground. Whereas there is another technology that is available in the geospatial context is the radar sensing, microwave radar sensing. There we use the radar radio waves for detecting. The advantage with radio waves is that it can penetrate through the clouds as well as the vegetation. So for the same date, we have this for 21st of August. We analyzed the radar data, so you can see that all these areas are flooded. Actually, these are the flooded areas, because you won't get it from the optical satellite, but you can get it from the radar images. Now we have just overlaid it. Once you get this, you can overlay it with Google Map and see which specific area is flooded actually. Now another advantage, since I spoke about archive data, one Copernicus European Space Agency gives data from 2015, but there is an American satellite called Landsat, which gives data from early 1980s, and they have some test data before that also. Now, if you look at this area, this is the Velayani Lake of Trivandrum. Those who are from Trivandrum may know this. This is one of the 3 freshwater resources of the state, and we have reading in the news that this has dwindled in size over the last several decades. Encroachment as well as sedimentation has caused the sizing down of the reservoir. So there are huge effort from the community and from the government to conserve this. So what we did, we took this radar image of this that clearly shows the extent, the boundary of current day lake, and you see like like a cloudy green. It's a blurred green here. Here it is very sharp. Here it's little blurred. These are all lotus, plant, which grows here. And this is the image. If you look at the date, it is 1973. So if you see this, see when 1973, this was the spread of the lake, and see how much it has reduced. It has reduced a lot. All the feeder streams, all these feeder streams are now, if you see, these are all feeder streams, small rivulets. I'm much familiar with this place. So if I go there, these feeders have become drainage channels. They put the slabs on the concrete drainage channels. So that is why it is getting. So it is the same image for the entire South Kerala and South Tamil Nadu, 1973. All these, it'll be very exciting. If you zoom it, since this is a screenshot of it, I won't be able to zoom it. But if the real data, you will zoom it, you can see the change that has happened for the last several decades. Now, towards the end of the previous talk, when I just logged in, somebody was asking me about the possibilities of research in drone images. Now, from this drone image, we have, even we have open source software to stitch together. When you fly the drone for a specific area, it collects individual photos, and you can see that in the the metadata will contain, for every photograph, the metadata will contain the geographic coordinate of the center point. So with this information, you can stitch together using the open source software to make it into something called orthophoto. Orthophoto is nothing but, ortho means, it is a Latin word for map. Photo is photo. So you are making a map from a photo. Normally from a photo, you cannot make any measurements because it has it's something called relief displacement. The view is like this. In map, it is like this. So the relief displacement is nullified. It will give like a map. That means you can make any measurements from the map. It will appear as a map with a photographic characteristics. And here also we are applying. You are getting. You can have different payloads. Just similar to the satellite remote sensing, where we have multispectral payload. That means in one exposure, it will collect the energy reflectance for green, red edge, and NIR. Then you apply this formula, NIR minus red divided by NIR plus. So the formula is this. Sorry, previously I said NIR plus red divided by NIR minus red. Actually, NIR minus red divided by NIR plus red. You apply this formula, it will give the NDVI. That means NDVI will reflect the subtle variations in the vegetations. So this is the same area which I spoke about, the Matupatti, this thing. With the naked eye, it will look like, so you see, it will look like green, but it has a lot of variations in the health of the vegetation. Now we have in GIS itself, we have a open source format called NetCDF, which carries multiple dimension data. That means, say this is the aerosol hotspots over India for 2018. So for a specific location, you can see that during the 2008, each block, this is one block, each tile in the block is a specific monthly data. May I attend the call? Is it a call from administrator? Am I exceeding the time or what? Administrator? Hello? Hello, am I audible?
Yes, sir. Yes, sir.
Okay. So can I continue or you want me to stop here? Okay, okay, thank you. So this is a visualization of aerosol density. You know, it's starting from 2018. Sorry, this is actually for the year. We have taken the weekly data. So each week is a block of data. ATM class. So the blue indicates the aerosol density is low. This is medium, and the red is high. Now you can clearly see, you know, you can interactively tilt it and see which season, in which area, which season you have the aerosol density is varying. By the way, aerosol is the dust particles in the atmosphere. So it is a boon and a bane, because aerosols will a particular category of aerosol will help for rains, and some other categories will cause respiratory problems. So you will see this aerosol density over metropolitan cities where you have you know, traffic density, traffic pollution is high. And moreover, we all know that, you know, during the winter seasons, especially in the northern metropolitan cities, this problem is severe. So the aerosol density is heavily used. The temporal variations of aerosol, seasonal variations of aerosol density is studied with the help of remote sensing data in a huge way. Now I'll quickly go through the sources where, if at all you are interested in exploring, or you want to give some assignments to the students, mini project to the students or projects to students. This is the link where you can install, you can download the software which I was showing, QGIS. And this is a free software from the Copernicus, which is called SNAP. So with the SNAP, you can do some pre-processing of the satellite data, which towards the end of this slide, I've given a small tutorial. And for the vector data, you can follow these links. You know, the organization like IC4 and people like Arun, they are initiating a huge effort in generating this data and making it available for the community, you know, license free. So these are some similar initiatives from our country where you can download this data without any license hassles. Now there is another type of data, very exciting data, which unfortunately I don't have time to show you. This is called digital elevation models. You can download this data and create 3D models of the surface. This is also extensively used in reservoir studies and, you know, soil erosion studies, and even for games. It will show the shape of the surface in a great detail. And some details about the European space missions and the satellites, which you can go through this slide. And the soil moisture data, which I you know, specified. This is the source from which you can download the soil moisture data. You know, whenever you get to know about a particular data source, couple of things you have to take care. That means, what is the temporal frequency? So the temporal resolution is daily. You are getting the daily data. What is the spatial resolution? What is the coverage? You know, sometimes what will happen is you may get the data only for North America. So you have to look for global coverage because these are all global missions. So the global coverage means you will get the data for India. And what is the spatial resolution? What is the temporal resolution? From where you, at what time they started, you know, disseminating the data. That's also the period is also very important. So similarly, fire data and biomass, then normalized difference vegetation index. Either you can download the raw satellite image and process it, or you can directly download the data, but the resolution will be a little different at an interval of 10 days. See, look at this. This is also very exciting. If you have a paddy culture, say for example in Alleppey, in rare cases, in some extremely rare areas, they have 3 crops. Normally it is 1 crop. Previously it was 2 to 3 crops, but only in some areas they grow 3 crops in an year. So starting from the preparing the land until the harvest, what are the changes that is happening to the crop? You can closely monitor with the help of this temporal satellite data. At the 10 days interval, you can monitor the health of the vegetation. Oh, sorry, I did something. Okay. I'm clicking the link, that's why. So this is leaf area index. Leaf area index is it's defined as half the total area of green elements to the canopy per unit horizontal ground area. This is also an indication of health of the vegetation. So NDVI combined with LAI can give you know excellent analytical possibilities. And I'll also give spectral index. There's a function available in R. So because I use R heavily, I'm not that much familiar with Python. So there is a library called RS Toolbox, Remote Sensing Toolbox. Within that RS Toolbox, there is a function called spectral indices. Now, the satellite image I showed here in the QGIS, like this one zip file. This one zip file, you read this zip file here and specify all these bands, it will produce, you know, 16 indices. Look at the indices. Each one is an index with respect to the vegetation. You can search any standard journal elsewhere or Sprinkler, anything, and you just search for this EVI, GME, and GNDI, MCARI. These are all specific indices which is used for studying the health of your agriculture or you know, or the forest or the plantations. All these things you can monitor. So leaf area index, soil water index. Then there are data available on nitrogen dioxide and then carbon, sulfur dioxide, atmosphere sulfur dioxide, and carbon dioxide. And this is something which is really catching up with the research. This is open data cube, which you can explore. Australia has implemented it, and this is actually, it is a repository of satellite data. You can just log in. It's a cloud-based service. You can just log in and you know, drag the different data, and with, you know, some languages, Python or this thing, you can apply some algorithms there and take out your result. If you're aware of Survey of India is a custodian of a type of map called topographic maps. Now they have made this data available free of cost, and from this site you can download this data. And this is the snap tutorial which I have specifically prepared for this talk. You can go through it. Because of the time constraint, I'm not going step by step how to download, from where to download. probably this version might have changed. And you go to Copernicus and register yourself. You have to register here to create an account, and then how to search the data. So I'm giving the remote sensing period, for which particular, you have to specify a period within which you are looking for the data, and whether it is mission 1 or mission 2. And if you want to learn, practice yourself, you can give the same values here and then try it, and it will show the tiles, because you have given a time band. So within that time band, so many satellite data are available. You just click this button, you will be able to download the data. When you download the data, you will see all these bands, band 1 to band 12. They have band B8A also. And then if you want to see the natural colors, because the raw image will be in gray levels, if you want to give natural colors of a band combination, see band 4, band 3, band 2, I'm taking this combination, and this is the filter, red, green, blue filter, and it will appear like this. It is called natural color because this is how it looks from space. Now you will do a trick. There's a concept in remote sensing called false color composite. There you interchange the bands. For red, you will give band 8. Band 8 is infrared region. That means whatever infrared energy is reflected, that is captured in the band 8. The advantage of using infrared image is that infrared is very sensitive with vegetation. Wherever you have chlorophyll, that will reflect infrared. If the chlorophyll content is high in the leaf, it will reflect more energy, more intense reflection. If the chlorophyll is less, intensity will be less. So taking that into the red, you will get something like this. So what does this indicate? Wherever you have very health and thick vegetation, it will be extremely red color, because all these are forests, dense forests. These are all paddy fields, and these are all something called garden land, because you will have a property of 30 cents. Within that 30 cents, you have the house, and remaining areas you have coconut, plantain, arecanut, all the mixed crops. So that will appear as like mottled. So these are paddy fields. Since it is a monocrop and it is a smooth texture, that will appear as a light smooth red color. Here it will be the intensity will be more, because the forest vegetation will contain very high chlorophyll content. And here also you can create NDVI. You just apply this formula, band 8 minus band 4 divided by band 8 by band 4. You will get the for the same image, this is the NDVI. So this is for downloading SAR images. Now you can see this is a radar image. The radar image will give cloud-free. In the previous case, if you remember, I choose mission 2, Sentinel-2. The Sentinel-1 will give you the radar image, which can penetrate through vegetation and cloud. That means the bare earth, the total bare earth, no vegetation, no cloud. So that you will get from the radar images. So these are some sources where how you can apply R with analytics, spatial analytics. And if you're looking for Python, you're a Python expert, then how you can use Python for geospatial analytics. These are some sites. These are some of the projects which we are currently working on for using all these geographic concepts and the technologies, mobile technology and web technology. We have developed a solution for rubber board for fertilizer recommendation, and this is something similar with animal husbandry, where we are tagging cattle, livestock farmers and cattle on the listing, so that in case of a disease spread, how best we can go with the vaccination. It's called ring vaccination, so that it is not spreading further, which is controlled properly. And this is a Hydra Drishti project which we are doing for Hydra Kerala, where we are collecting the assets like the ponds, wells, lakes, then agriculture, then waste management, all these micro level information from the ground. And this is similar to rubber board, rubber cultivation. This is a fertilizer recommendation for all the crops grown in Kerala. We have covered some 53 crops with 89 varieties of fertilizer recommendation you will get from this. This is available in Play Store. This is a project for Ministry of Earth Sciences, Government of India, where we are mapping the sacred groves and studying what is the carbon stock with the sacred grove and the floral diversity index of the rare species of the sacred groves. And this is a census of rubber growing farmers. This is a wonderful initiative from government. In they have identified selected higher secondary schools where they're strengthening the chemical laboratories there, and students are requested to bring water samples from the nearby areas, and the samples are analyzed in the respective higher secondary schools and uploaded to the repository for interventions. And this is again explaining this one particular project would take one presentation, because this is a fantastic project for progeny testing. High yielding cows and calves, how we can monitor through the time, generation by generation, how we can monitor this. So that is from my side. It was I know that it was a rush through presentation. Because I do not want to trouble you, because I'm standing between you and your lunch. So that is why I had to rush through. Where is the... Yeah. So any doubts? Can I take any doubts? I hope there is no doubt from the participants. So shall we conclude?
Dear faculties, if you have any queries, then it's a time to ask. I think Bergen sir is typing.
Yeah.
Yeah.
Okay. Contact details. I'll give my email ID. Sri Arun. At Administrator, are we sharing the presentation in PDF form or something?
Sir, it will be good if you're sharing the presentation.
Fine. Then I'll do one thing. I will include my contact details in the PPT so that if anybody is interested to, clarify something, they can contact.
Okay. And also, sir, we have a Telegram group and WhatsApp group. So if you are interested, then you can join in that group. So you can find their queries in the groups and you can answer them.
Perfect. But how do I join there?
I will send you the link personally, sir.
Oh, okay. I'll install the Telegram. I have not installed it. I'll install it.
Okay, fine. Okay, so I think we can wind up the session, right? It's 1:30 right now, so I think we can wind up the session.
Yeah. Thank you.
So there's a formal thanks note from our side. I'm inviting Felicia for delivering vote of thanks.
Okay. So thank you, sir. We are very much pleased to have you here. And thank you so much for your valuable speech and contribution. So please take up a token of appreciation in the form of a virtual memento, sir, for making this program a great success.
Thank you so much.
Thanks.
Okay, thank you, sir. Thank you very much for a wonderful session.
Thank you.
Okay. Okay, so it's already 1:30, so I'm not ഞാൻ കൂടുതൽ സംസാരിച്ച് ബോറടിപ്പിക്കുന്നില്ല. സോ ഇനിയുള്ള 2 ദിവസങ്ങൾ കുറച്ചും കൂടെ ഇമ്പോർട്ടൻ്റ് ആണ്. ലൈക്ക് there is a panel discussion and also we are planning the annual activities of FOSS Cells also. സോ ഇനിയുള്ള 2 ദിവസങ്ങളിൽ നിങ്ങൾ കുറച്ചുകൂടെ ആക്റ്റീവായിട്ട് നിൽക്കാൻ ശ്രമിക്കണം. ഇറ്റ്സ് എ റിക്വസ്റ്റ് ഫ്രം മൈ സൈഡ്. സോ I will be dropping mails time to time and സോ ഞാൻ നേരത്തെ ഒരു മെയിൽ അയച്ചിട്ടുണ്ടായിരുന്നു നിങ്ങളുടെ ചാലഞ്ചസ് നാളത്തെ പാനൽ ഡിസ്കഷനിൽ അഡ്രസ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ്. സോ ഇതുവരെ എനിക്ക് റിപ്ലൈ ഒന്നും വന്നിട്ടില്ല. സോ ഇറ്റ് വിൽ ബി ഗുഡ് ഇഫ് യു ആർ റിപ്ലൈയിങ് ടു ദാറ്റ് മെയിൽ. സോ എനിവേ താങ്ക് യു ഓൾ. Thank you very much. See you tomorrow.